Hi guys, good evening. So I'm Calvin and I work in this exciting area called artificial intelligence. So I know most of you would have heard about AI. I mean, it's the most spoke topic these days. But what I'm going to do is I'm going to show you and talk to you about some real world use cases which we are working on with some of our customers. So you'll see actual demos and videos which we work with our customers. So I won't be disclosing those customers' names in the presentation, but you can talk to me after the session and I can tell you what exactly those solutions are all about. So before we get into the real world cases and what's happening at the present and in the future, let's just take one step back and see what is this drama all about AI, right? Why are we talking about AI? How is this evolution happening? So if you look at the history of artificial intelligence, it's not something that started about 4 or 5 years back. It's something that had been evolving from 1960s to 1970s, and then the late 1980s to 1990s. But if you take the present 4 to 5 years back, we all saw a tremendous growth in AI, a tremendous development where you saw AI applications being implemented in almost all of your day-to-day applications which you use, right? From your social media applications to your email clients. Every application out there has some kind of AI capability now implemented. So why is this? So can anyone tell who this person is? There are gifts out there, probably we can give you more gifts. So this guy is called Jeff Hinton. He's actually the godfather of neural networks and considered one of the main guys who thought about this entire concept of computers acting similar to the human brain. So in the late 1970s and the 1980s, he came up with this cool idea, thinking that whether he can create a machine, a computer machine, to act like a human brain. And in the late 1970s and the 80s, people thought that this guy was crazy. So he was doing tremendous experiments and research, but most of those stuff were not successful. There were many reasons. So I just want to play you a video so that you can identify how this AI has been evolved and why we are talking about artificial intelligence in this era like never before. So I'll just show you that video.
We didn't work quite well enough because we didn't have enough data, we didn't have enough compute power. And people in AI and computer science have decided neural networks with wishful thinking reasoning. So it was a big disappointment.
Through the 90s, into the 2000s, Jack was one of only a handful of people on the planet who were still pursuing this technology. He would show up at academic conferences and be banished to the back rooms. He was treated as really like a pariah.
Was there like a time when you thought this just wasn't going to work and you had some self-doubt?
I mean, there were many times when I thought, I'm not going to make this work.
But Jack was consumed by this and couldn't stop. He just kept pursuing the idea that computers could learn until about 2006, when the world catches up to Hinton's ideas.
Computers are now a lot faster. And now it's behaving like I thought it would behave in the mid-80s. It's solving everything.
The arrival of super-fast chips and the massive amounts of data produced on the internet gave Hinton's algorithms a magical boost. Suddenly, computers could identify what was in an image. Then, they could recognize speech and translate from one language to another. By 2012, words like neural nets and machine learning were popping up on the front page of the New York Times.
You have to go all these years and then all of a sudden, in the span of a few months, it just takes off. And I finally feel like, aha, the world has finally come to my vision.
It's sort of a relief that people finally came to their senses.
So what was the main 2 points that elevated AI to the next level? If I may ask you again, what was the main 2 points? Anyone? It's data and the compute power. So just think about your organization. Probably they would have been, operating with data, for the past 10 or 15 years. So massive amount of data is there now. So in the past, when Hinton and the other scientists were doing this research, there wasn't any much of data. And the compute power was very low to run these algorithms, these machine learning algorithms. But now with the amount of data and compute power, AI is not a science fiction anymore, it's reality. So when you talk about AI, you've probably been hearing many of these jargons, right? Call it machine learning, neural networks, cognitive computing, vision recognition. So what does this mean, right? Is it just jargons out there, or how do you categorize AI? So as I explained previously, neural networks is the main concept behind AI or machine learning. It's how a computer functions similar to your brain. That's why it's called neural networks. So it has neurons, but digital neurons. So machine learning is the algorithms that run on top of these neural networks. So there are many machine learning algorithms. We call it, supervised learning, classification, regression. I'm not going to go into detail, but I'll show you some of the stuff which are working with some of our customers. And then there's another area called cognitive computing. That is how a machine can similarly act like a human being, what the machine can see, what the machine can hear and talk to, and probably understand a language. We all see this capability, right? So what I'm going to talk about today is some of these areas, and I'm going to take each area and show you some of the example use cases that we are working on with some of our customers. So let's take computer vision. So computer vision is all about what computers can see out there. It can be objects, it can be a person's face, it can be emotions, whatever. So whatever it can see out there, what are the kind of insights and analytics it's trying to derive out of this. So we thought how we can use machine vision recognition for some of our customers' problems out there. So we are working with many banks out there. We are working with apparel manufacturers, using vision recognition to make their tasks more efficient. So these are some of the areas that we're working on. So one area is which we call digital onboarding, specifically for banks. So how all the banks are going with mobile applications, and we see some of the banks out there using face recognition to onboard their customers. Yes, but the central bank has not approved this completely, but the technology is there to do it. Then we see how we can use face recognition and vision recognition to identify customers' emotions. We see how we can identify customer demographics. Say when customers enter your retail stores or your branches, how we can identify the type of customers that are entering those places. So security assessments. So I'll go into each area and show you what we're doing. So digital onboarding is one area which I told you about, which banks are now looking into. So the idea is you take a selfie, you show your national ID card or driving license, the vision recognition algorithm maps it, and you're onboarded on the application or you're authorized. But we know with the Sri Lankan national ID cards and the driver license, I mean, those pictures are like taken 10 or 15 years back, right? Sometimes you will not recognize yourself even. Yeah, so what we did with the vision face recognition algorithm is, so we did a POC with some of our employees. We took about 200, 250 pictures, real pictures, and some of the driving licenses and national ID cards. And we trained the engine to identify, whether it's the same person. So this picture on the left, which you can see, is one of our employees. That is the picture taken from her driving license. You can see it's black and white. It's not clear also. And then this is on the right-hand side is a picture which was taken recently. So when we train the engine, now it's able to identify whether this is the same person. As you can see, it says a confidence level of 0.61. It belongs to the same person. So with the continuous training, so most of the people think that AI is just a plug and play thing. You plug it and it works. It doesn't work like that. It needs tremendous training So it's a lot of training, and it's not something that can run on its own. You need continuous human intervention to get it better and better. So what about if someone tries to fool the system? If he tries to hold a 2D picture in front of the face recognition or a video from his iPad or something. So this is where we have this thing called face liveliness detection. So what happens is our algorithms can track the 3D depth of whether it's a real person or not. So by that we can actually tell whether this is a real person or a false, whether it's a 2D fake image or it's not a real person. And these are some of the other use cases, like we can tap into any of your CCTV cameras, and using that stream, we can identify the type of people who are entering your stores, your company premises, if it's bank, the bank branches. And doing this, we can identify the demographics of the customers, like what are the type of customers who are coming to these branches. And say if it's a VIP customer, we have identified space, we can notify the branch manager. And if people, try to come in, wearing helmets, covering themselves, trying to do some kind of activities, we can assess those as well. So this is all done by vision recognition. Wherever a camera is, we can plug into it and get those insights. So this is actually another use case we did with one of our employees. So this is called custom emotion detection. Say one of your agents in your bank or retail store is engaging with your customer. So even before the customer comes and speaks to the agent, the vision recognition engine will identify him and his name, and even identify him and give his age, plus it will track his emotions when he's having a conversation with the agent. So by this, you can kind of identify how the agent is handling your customer, right? But we all do this having the consent of the customer. We have to tell that you are being monitored, because some of these use cases, when we spoke to Microsoft, they have implemented this in India, but you always have to tell the customer that you are being recorded. It's not ethical. So then, when it comes to smart self-service, we have a lot of kiosk solutions, ATM solutions, basically solutions that can engage with your customer without any human interaction, right? So specifically, if you look at banks, there are ATMs, there are kiosk solutions, many types of devices out there. But how we can use AI and vision recognition to make it smarter. So I'm going to share you a use case where a bank in China is using vision recognition, and all their transactions are just done by identifying the face. So you don't need any cards or any documentation whatsoever. So let's just take that out.
It used to be if you wanted money at an ATM in China, you had to have a card.
我这样子修卡就不用把所有
If I brought my card and lost it, I would have to reapply, which is really troublesome.
But now all zoning needs is her face.
然后直接人过来
Withdrawing money like this, I do not have to put all my bank cards in my purse.
Zoning is a customer at the Agricultural Bank of China, whose ATMs come with facial recognition technology. The machines come with cameras that scan the client's facial features. They're then compared with a photo from their national ID card.
一定要确保它就是
The captured facial features should be in line with people's identification cards. For example, foreheads should be exposed. And for eyeglasses, if a person did not wear eyeglasses when applying for his or her identification card, the person should remove his or her eyeglasses.
A confirmation of their
So I'll just skip the video since we don't have much time. So these things are actually capable. So we are doing a lot of products in these areas and solutions. So we're using the Microsoft machine learning capabilities to train our engines out there. So this is a use case where we have implemented a smart kiosk solution where we're using vision recognition to identify the customer and greet the customer. So the customer comes in front of the kiosk, and within 400 milliseconds, using vision recognition, we have trained the engine to identify the customer and greet the customer as well. So in the other use case, so you have gone to ATMs, right? And there are many signs saying you cannot, withdraw money or do transactions with your helmet or sunglasses on. So are you going to 24/7 monitor that? How would you know? And how will you kind of stop those kind of transactions if someone comes at that? So we can do that with object detection. So once a person comes in on front of the kiosk or the ATM, using this we can identify whether the person is wearing some kind of helmet or some kind of equipment to cover himself. If so, we can track that and then stop the transaction or tell him to remove these from himself. So the next use case which I'm going to show is something really touching. It's how AI is being used to help disabilities. It's a project done with Microsoft, and see, most of the time we think about technology in aspects of how we can grow revenue, how we can improve our business. But what if we can use that technology to change someone's life? That thing is speechless, right? So let's just take this out.
I'm Sakib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind. And that's where it was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives. And one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces. 40-year-old man with a beard looking surprised. 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Using menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do, but artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before, and in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
So actually you can go and download that app. It's called Vision AI. It's supported for Android and iOS both. So those are some of the cool things that we can do with Vision. So with the little time available, I'm now progressing to speech recognition. So speech recognition is all about what machines or computers can hear and what they can derive inside of the audio. So a couple of areas we are working on vision, voice recognition. We have heard about bots, right? Chat bots. So we are working on a couple of bots which can understand, voice, speech to text, text to speech. And the most important thing is we are kind of customizing these solutions to support the local context, like understanding Sinhala, Tamil, Singlish. Because at the end of the day, whatever solutions we put out there, our market or the customers are more comfortable in communicating with the native languages, right? So that's why we focus on how we can localize these solutions. So I'm going to show you a couple of demos on how we are using voice recognition bots to interact with customers. So we have done this for a couple of banks. We are working with some of the government agencies out there. Like I said, you can always talk to me after the session. So voice recognition, you all have seen the Google duplex demo, right? And you all know where voice recognition is headed to. in the couple of, probably next year, your next call center agent might not be a human being. It might be an AI bot who is communicating with you. So this is where things are headed to. Because it adds real value, right? Those kind of repetitive tasks can be automated by these bots, where you can enable your human agents to work on better tasks than those same old tasks over and over again. So going into the demos, so this is a demo that I'm showing how we can use speech to text in English. So pardon me, this is my voice, so it's not cool like Amazon Alexa or anything. So let's just go through the demo. So it's using conversational AI. So conversational AI is just not saying the keyword, but having a normal conversation like with another person.
I want to apply for an account. I think I want to apply for loan.
So see how I say an entire sentence without just saying loan. So I'm having a
What's your contact number? Thank you so much.
So the other common request we get from some of our customers is whether this can be catered to understand Singlish, because many people out there on social media and digital, they have conversations in Singlish. So let's see whether we can pull that off as well. So see how it identify the Singlish keywords from English and the single Unicode fonts, and then we can kind of have the knowledge base also customized. Now the next thing is, what if we can talk to the bot in singular, and if the bot can respond in singular also. So this is something that we are doing a lot of research and POC, not only using Microsoft, but using a couple of other solutions as well to get this to a reality.
Number 48 සමාපත්තන මාද කොළඹ
තිරේ සඳහන් වන ලිපිනේ නිවැරදි නම් ස්ථීර කරන්න.
ඔව්.
ඔබගේ දුරකථන අංකය ඇතුළත් කරන්න.
0.777
තිරේ සඳහන් වන.
So that is how we are trying to customize the voice recognition capabilities for the local language. So we are working with the government agency to enable some of these chatbots to be available in all the languages like Tamil, Sinhala, English, and even Singlish. So moving on, so we spoke about vision recognition, we spoke about voice recognition. Now the other area is which you call language understanding. So language understanding is all about what machines and computers can understand. Probably what your customers are talking about on social media, probably through chatbots, probably through mail. So how can a machine read those contexts and derive insights out of it? So some of the areas we're working in language understanding is which you call sentiment analysis. So sentiment analysis is like, for example, if a customer goes and posts something on social media, whether it's a negative or a positive, or this customer is unhappy, or this is a happy customer, those kind of conversations, and how we can get those analytics. And also how we can auto-respond to customers. So one area is which we are working with language understanding is the chatbots. So I think all of you must be heard about chatbots, right? It's another topic which is spoken about a lot these days. So I'm going to show you, so everyone talks about AI chatbots, but are they really smart, right? Because not all chatbots are AI chatbots. So there are several types of bots. So one which we call is not actually AI, it's kind of a dumb bot. So what happens is it's like a decision tree. So for example, the customer comes in and think of a banking scenario where the chatbot gives a couple of options and the customer can have the conversation just by click events, right? So there is nothing AI here, it's just a decision tree, which actually serves the purpose in some instances. Then we go to stage 2, which we call natural language processing or free typing. That's the customer can basically type in a conversation, and we use this natural language processing engine to identify keywords and the meaning of those sentences and reply accordingly. So that is what we call natural language or free conversation. Now, the other thing is which we call conversational AI. That is, you can have a free conversation with the bot. So let's take an example. Let's take the previous example. So the customer says what type of credit card offers you have. And then the bot responds. And then can you see how the customer says, can you share me the locations of those stores? And then the bot gives the locations to Google Maps, pointing those stores. And then finally, the customer says, okay, thank you. Also, can you tell me till when this is valid? So see, the final sentence was just a conversation, not saying a specific word, but relating to that conversational history. So this is called conversational AI, where actually the bot keeps the sessions of the conversations and responds. So this is where actually things get a bit smarter now. So the other thing is integrations. Now, whatever I told you up to stage 3 is just knowledge-driven bots. We feed the bot the knowledge and it can do things. But once you integrate bots to your backend systems, for example, like if the customer wants to know about your credit card balance or account balance, we can actually integrate the bots into the backend systems and pull in information. So there are a lot of bots. There are customer-facing bots, and also there are internal bots where you can use for HR activities, to apply for leave. So we are working on a lot of those areas. Of course, for this, we need to think about the security aspect. I think Buddhika will be very happy to work in this area. So, because we need to think about the encryption, the tokenization, how we are pulling information from the backend, and also the session deletion, because once you pull in certain information from the backend, you should delete it from the chat history, right? So these kind of methodologies can be used. So only when you implement all of these areas, you can actually think about a smart bot. But you cannot actually implement all of these areas at once, because you should start from somewhere. That's why we say you should start with a basic FAQ and a conversational bot to share information with the customers. And only after you get an amount of conversations on the real world customers, you should proceed to the next integration points. So that is the kind of best practice which is happening out there. And finally, I just want to share, so I spoke about most of the cognitive stuff, the vision recognition, voice recognition, and the language understanding. Now, we do a lot of projects with machine learning predictions. So I'll just share you some of the projects we are doing right now without disclosing the customer's name. So one project which we are doing with the apparel manufacturer is that to have a machine learning model for their IT support. So what's happening right now is that IT team is being bombarded with about 3,000 service requests from mails, from calls, from chats. So 3,000 SRs per week. And when it identified that, more than 30 to 35% of those SRs are repetitive stuff. Like my password is not working, I'm going to log into this, repetitive stuff. So what we did was we made a multi-class classification ML model to kind of train the engine to identify this. So now what happens is, when these 3,000 SRs come in, it will first hit this ML model. And because it's trained now, so we took about 4 to 5 years of data from their ticketing system and trained the engine. So when it identifies a problem which has a solution for it, the engine itself will reply to the employee through mail or through the Skype bot, so that the engine will try to solve the problem there and there. And if the problem is solved, the SR will be closed automatically. And also there are about 5 guys who are manually reading mails and chats and creating the SR manually on the ticketing system. But since we are now trained the engine, the machine learning will read the email or the chats and automatically categorize the SR as well. So these are some of the areas where working on. So this is done all with machine learning training, and for this actually for doing some kind of predictions you need considerable amount of data because more the data, the more accuracy that your prediction algorithms will work. So we took about 4 or 5 years of data, and right now we are at about 65% accuracy, but we believe we can take it up to about 70 to 75% once this goes live with the new data coming in. Also, we are working on another area. I think Melinda, you might be knowing this one. So we are trying to work on so this is regression ML. So what we are doing here is, this textile manufacturer, once an order comes in, right now they are planning the production on their experience. But they have data in their ERP, in their other financial systems, more than probably 6 or 7 years. So we're going to take that data and using a regression ML model, so the next time that a production order comes in, the ML will give the employees the insight saying, with the previous data, these type of resources you need, these are the material you need from the warehouse, these are the kind of machines that are performing well for these kind of orders. So those kind of insights and predictions can be derived from this ML model, so that they can take better decision making. So before I end my story, so I spoke about vision, voice, natural language processing, and predictions. So all this now, where do you think this world is headed to, right? So have you heard the theory of singularity? Yeah. So what singularity is saying that in the next 30 to 40 years that AI will write its own algorithm. So probably it's no problem for me because for the next coming guys who are going to learn AI, they might not have jobs. So it's like AI going to give birth to, AI, right? So that's what singularity is all about. So if you look at the pace AI is, developing, it's probably going to happen. And has anyone watched iRobot or Terminator? I'm very sure you have. So things are headed to that way. So just see this video, I don't know if you have seen this. So this is AI, robotics, all working together. And it's something done by Boston Dynamics, a company that works on advanced robotics using AI and all of that. So this is so that's something cool. So you can actually see where things are headed to with the rapid development. But the question is, are we thinking about the ethical side of this? These technologies are good when it's used for the betterment of human beings, but what if it's used for bad things? So that is why we read a lot of theories and concepts about this thing called AI ethics, on how when you're using this technology to use it in a positive way. You saw the recent incident with Facebook breaching so much of data, right? That's just the tip of the iceberg. That's just a social net. Just imagine in this era of nuclear warfare, some bot go ahead and triggering a nuclear missile. Simple thing can happen like that. So that's why we need to think about the ethical side, how we use this technology, and how we use it in a positive way for businesses, for customers, for organizations, and so on. So yeah, that's about it. So you can talk to me after this session. I can share you the actual use cases that we are working with customers. So we are working with a lot of banks. So we are working with some of the biggest apparel manufacturers out there and government agencies in this AI space. So you can always visit my blog. I always try to share my knowledge, writing about the next stuff which is happening out there. And you can contact me through LinkedIn as well. So thank you.
Thank you, Calvin. So we have come to the end of today's official part of the session. Let's give a big round of applause to all the speakers. I'm sure you all enjoyed it tremendously. I've actually watched that video of that blind gentleman about 20 times now. It never gets old to see what we can do with technology. And it's unbelievable if we can actually take technology and affect change in people's lives. As the speaker said, we stand on the shoulders of giants, we can move mountains, right? And the problems that you have in your organizations today actually can be solved with simple technology like that, and we can actually equip people with the right tools. So if you want to learn a lot more about what we can do, I would like to invite all of you to the poolside for some cocktails and some conversations. And also when you're leaving, please collect this small token of appreciation. Please collect that from the entrance, and look forward to catching up with all of you outside. Thank you very much. Thank you for coming today, and thank you for taking your time off. And we sincerely hope you learned something today. Thank you very much.
वीडियो निकाल